Today we're talking about piecewise functions. This is number 3 in your notes for your assignments in Google Classroom, PowerSchool. And piecewise functions are exactly what it says, basically. They're taking pieces of different functions and putting them together on a graph or just putting them together. So the first thing we're going to look at is evaluating them for a certain value. So if you look here at f of 7, remember, it's a function of x, so that's telling us that our x is now 7. When we're doing this, we have to look at our constraints. These are called constraints, okay? So this function here, for all values greater than 4, we use 3x minus 5. For all values or x values less than or equal to 4, we will use x squared. So again, we're looking at 7. 7 is greater than 4, so we're going to use 3x minus 5, okay? And we will plug the 7 in. So what do we get? 3 times 5 is 15. 15 minus 5 is 10. So for this piecewise function, the value of y when x equals 7 is 10. All right, so if we take a look at number 2, we're looking for when x is equal to 4. So this says x is strictly greater than 4. 4 is not greater than 4. We're looking for when 4 is equal to 4. So that is less than or equal to means we're going to use this one. So we're using x squared this time. And our x is 4, so 4 squared is 16. So for this function, when x is equal to 4, our y is 16. And number 3, our x value is negative 3. Negative 3 is not greater than 4, so we're not using this function. Negative 3 is less than or equal to 4, so we're going to use x squared again. So negative 3 squared is 9, and that's the value there. All right, so let's look at this one. Here we have 3 pieces that we have to look at. This is number 4 is looking for when x is equal to 10. So is 10 less than or equal to 1? No. Is 10 between 1 and 3? No. 10 is greater than or equal to 3, so we're going to use this one. 6 minus 2x. 6 minus 2, and our x is 10. So 6 subtract 2 times 10 is 20. 6 minus 20 is negative 14. That is our answer for that one. Our next function, we're looking for when x is 2. So is 2 less than or equal to 1? No. Is 2 between 1 and 3? It is. So we're going to use this function. Notice this is a 3. We do not have an x to substitute 2 in for. This is just a constant function, which tells us that y is always 3, no matter what x is. Remember this function from the first page of our parent function booklet, so the answer is 3. And then last one is 0. Is 0 less than or equal to 1? Yes, it is. So we're going to use this function. Negative 2 times the absolute value of 0 plus 1. So we treat our absolute value bars like we treat our parentheses, and we will have to do what's inside first. So what's 0 plus 1? It is 1. What's the absolute value of 1? It's 1. So I took the absolute value of it, and negative 2 times 1 is negative 2. Now we're going to graph these. And the easiest way I have found to graph them is to make tables. So we're going to look at each piece and graph them that way. So looking at these are two constant functions. So we should know that we're going to have two horizontal pieces. I'm going to look at this piece first. And I'm going to set up a table. Well, and the y equals -2. And this is only for x is less than 0. So I'm using 0 as my starting point because it's not going to go any further than 0. And it's all x values less than 0. So I'm going to pick a couple of x values that are less than 0. Okay, so a reminder, this is a constant function. We don't have any x value to plug in for. It's just always going to be -2. So this should be short and simple. Okay, again, since this is all values less than 0, we have to use 0 even though it's not included because there are so many numbers in between -1 and 0, but we use an open circle for our endpoint, okay? So if I look at this part, I have 0, -2, and I'm putting my open circle endpoint there. -1, -2, -2, -2, and it keeps going horizontally in the negative direction. Now let's look at our next part. All right, so I'm going to make a little table for this one also. So this is the y equals 3 part. And again, I'm using 0 as an endpoint. And we want the x values that are greater than or equal to 0. So greater than 0 would be 1 and 2. The equal to part means I'm using a point, closed circle, whatever you want to call it there. And again, since this is a constant function, y value is always 3. So what does this look like? We go to 0, 3. We put our closed circle endpoint, 1, 3, 2, 3, and it is going to go in this direction. All right, let's look at one that is not a constant function. These, hopefully you recognize as two linear functions. So I'll start my tables here. I'll start with this one, -x plus 2. And I start with 2. There's going to be an open circle at 2 because it's less than, not less than or equal to. And then I pick some numbers less than 2. I have 1 and I have 0. So if I plug in 2 for x, I have -2 plus 2. That's 0. If I plug in 1 for x, that's -1 plus 2. That's a positive 1. And then if I have 0, -0, or 0 plus 2 is 2. And then it keeps going. So 2, 0. I put an open circle here. 1, 1. 0, 2. And I keep going in that direction for that piece. Then I have x minus 2. So I'll make me a little table for that one. I will start with 2. It's a closed circle because it's greater than or equal to. And the greater than values would be 3, 4, and so on. So plugging in 2 minus 2 is 0. 3 minus 2 is 1. And 4 minus 2 is 2. So I'll go to 2, 0. And what happens is now I get to fill in that circle because we are actually using that circle. 3, 1, 4, 2. So it almost looks like or it does look like an absolute value function. This function is called a continuous function because it is connected. This function is called discontinuous because we have a break here. It does not connect all the way through. Okay, we have negative 3x plus 2. So we start with 2, and that's a closed circle because it's less than or equal to, and some numbers or values less than 2 are 1 and 0. So I will plug these in. So 2 times negative 3 is negative 6, plus 2 is negative 4. Negative 3 times 1 is negative 3, plus 2 is negative 1. And 0 times negative 3 is 0, plus 2 is 2. So we'll plot these points 2, negative 4, 2, negative 4, close circle here. 1, negative 1, 0, 2, and it keeps going in that direction. And then here I have this function. So 1/2 x minus 4. Now, we're going to start with 2, open circle, and then we have x values to pick that are greater than. You can pick 3 and 4, but if you notice, you're going to have to take half of it. The easier thing to do is to pick even numbers that you can take half of. So I'm going to do 4 and 6. Doesn't matter either way, but that's what I'm going to do. So half of 2 is 1, minus 4 is negative 3. Half of 4 is 2, minus 4 is negative 2. And half of 6 is 3 minus 4 is negative 1. So I'll start with 2, negative 3, which is very close, so it's kind of hard to tell what I'm doing on my graph. 4, negative 2, 6, negative 1, and I will continue my graph that way. Number 10. We have 3 pieces this time. We have a constant function at 4 for negative 2 and below, or less than, and that's less than or equal to, so that will be a closed circle. And again, constant functions are easy, no work to be done there. Negative 2, 4, negative 3, 4, negative 4, 4, it just keeps going that way. Now we have this middle part, and we haven't had one with a middle or 3 pieces. So here what you have to notice is we're going to have 2 endpoints, okay? So my function is x squared, and I'm going to have 2 endpoints, negative 2 and 2, and then I'm going to pick a value to go in here. Now look, this is less than or greater than, flip backwards, and less than. So we have open circles for both of my endpoints here. And an x value in between is 0. It's right in the middle, so that's what I'll use. So I'll plug it in. Negative 2 squared is 4. 0 squared is 0, and 2 squared is 4. And hopefully you recognize that this is a quadratic. It's a parabola. It's going to look like a U. It should look like a U. And the fact that we have this, I can tell we have that part. So negative 2, 4. Again, they overlap. 0, 0, and then negative 2, 4 here. So even though it kind of looks like with just those 3 points, it would be like a V, I'm making it a parabola. Now we have to do our last piece of our function, which is going to be very similar to the first piece because it is also a constant function with a value of 4. This is a positive 2 for our endpoint. It's closed because it's greater than or equal to, and the greater than numbers I'm choosing are 3 and 4. So here's our table. We have 2, 4. So I'm filling in that open circle. And then everything else is 4. So it's another horizontal line. So here, this is another discontinuous. And this one is a continuous because it's connected. And I ran out of room, sorry. We have 2 more to discuss. So for 11, we're going to start with the first function at the top. We have 3x plus 12. The endpoint is at -3. It's a closed circle, and it's less than, so I'm going less than -3. Plug this in, so -3 times 3 is a -9 plus 12 is 3. -4 times 3 is -12 plus 12 is 0. And -5 times 3 is -15 plus 12 is -3. I'm going to start with -3, 3. So -3 up 3, close circle, -4, 0, -5, -3, and I'm going that direction. My next function is the absolute value of x, so it's that parent function. So you could even use your booklet probably to fill this one in. Again, it's a piece that's going to have 2 endpoints, open circles at both of them because it's strictly the less than symbol. And in the middle, I'll pick 0 again. So the absolute value of -3 is 3. Absolute value of 0 is 0. Absolute value of 3 is 3. So I have an open circle at -3, 3. Oh, wow. This one's going to look very similar to the other one. 0, 0, and 3, 3. And don't forget that the absolute value function looks like a V. And the last part of our function, this one does look very similar to the last one, is going to be -3x plus 12. Endpoint is at +3, closed circle, and greater than. -3 times 3 is -9 plus 12 is 3. -3 times 4 is -12 plus 12 is 0. And that's -15 plus 12 is -3. So I'll go to 3, 3, fill in that circle, 4, 0, and 5, -3. And this goes in that direction. So it looks like an M. Last one. I have 2 pieces to this one. For the first piece, we have x squared minus 4. The endpoint is at 3. It's an open circle, and we want less than, so I'm going to 2 and 1. Plug in my x values. 3 squared is 9, minus 4 is 5. 2 squared is 4, minus 4 is 0. 1 squared is 1, minus 4 is -3. 3, 5. And by the way, this is a quadratic, so we may or may not see our U shape, but I feel like we should. 2, 0, 2, 0, 1, -3, 1, -3. And look, I can tell here that I'm getting my U-shaped. So what I need to do is keep going. I actually know because of my transformations notes for number 2, that this is going to be the parent function shifted down to 4. So I actually know this is where my vertex is. So if I have 0, -4, and then I go to -1, -1 squared is 1, minus 4 is -3. Here's where you can see that it starts going back up. So be aware of what these functions should look like when you're graphing them to make sure you get all of it. Then we have our second piece. So 2/3 x minus 5. 3 is the endpoint. It's closed circle, and we want x values greater than. Oh, and you know what? I'm taking 2/3. So if I have multiples of 3, this is going to work out a whole lot better. So that is what I'm going to do. I'm going to change what I've chosen. You can stick with 4 and 5. You'll just have fractions, and you can graph those. But if I go to 6 and 9, this is going to work out a lot prettier. So 2/3 of 3 is 2, minus 5 is -3. 2/3 of 6 is 4, minus 5 is -1. And 2/3 of 9 is 6, minus 5 is 1. This is a linear function, so this would look like a line. And I just realized that I made a closed circle here, but it should be an open circle. So I have 3, -3, 6, -1, and 9, 1. And that is not right. So I found my mistake. I had gone over one too far. This is linear right here. So this one is discontinuous. This one is continuous. And that's the end of our notes.